Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today, as with most of my screencasts, I'll be discussing the reciprocal system. In this case, the reciprocal system Microcosmos database. You can see the main menu, the Microcosmos database here on the left, and the reciprocal system Macrocosmos database main menu on the right. I've already covered all of these layouts in previous screencasts, so you may want to check them out. Last week I covered interatomic distance for solid state properties. So today we're going to look at the next layout, which is valence. Now I should point out that it would be worth your time to very carefully study Dewey B. Larson's work, Nothing But Motion. There are several chapters on valence in that work, and what I've done is to make everything computational here. I worked with Dewey B. Larson from 1965 until his death in 1990. He was the best possible mentor one could have. Alright, so let's click on valence here. And like last week, we'll go with iron, but all the elements are in here together with many, many compounds. So there's description, of course, the form number, as I've explained in previous screencasts. You can have multiple records for an element or a compound if you wish, if you want to have different, enter in different data. Molecular weight is here, melting temperature is here, thermal factors and compressibility factors are here. Now for these factors you need to read Dewey B. Larson's work, Basic Properties of Matter. Okay, now we can do two elements at a time, so an element or group 1, element or group 2. In this case we're just dealing with solid iron. These are the possible rotational speeds, as they're called, which are derived from the rotational displacement. So the 320 morphs into these possibilities here, and on the second side it maps into these possibilities here. By the way, this is the radius in femtometers. The atom in the reciprocal system is the same size as the nucleus of the atom in conventional theory, so just keep that in mind. So we don't have to postulate things like neutron stars, because in fact so-called neutron stars are really composed of atoms, because the atom is really no bigger than the size of the nucleus in conventional theory, so there's no problem there. Alright, so let's look what else we have. Now we can have different sets of possibilities, meaning there can be different types of bonds. Now ordinarily with the metallic solid it's going to be a positive bond. So in this case it'll be 4-3 for the magnetic specific rotations and 8.5 for the specific electrical rotations, and the same for the all the other atoms. In this case both sides are the same. So if we have a neutral or magnetic positive bond type, we get 2.47 angstroms for the interatomic distance. If it's the positive bond type, which is the normal type for metallic solid, it would be 2.5704 angstroms. So here we can, here we put in the displacement, so you can see 328, and I'll make sure I said 328 up here as well. Okay, so it's the same on both sides, but it doesn't have to be if we're dealing, and I'll show you a compound or compounds in a little bit. So the most probable valence type is where you put in here. This is positive electric, but here, look at all these choices. You can have, the positive electric is for metallic and non-metallic. Then you also have normal electric, zero electric, neutral electric, secondary neutral electric, secondary positive electric, enhanced normal electric, enhanced neutral electric, primary magnetic, secondary magnetic, enhanced primary magnetic, enhanced secondary magnetic, diminished primary magnetic, and diminished secondary magnetic. So I went through all the elements and many, many compounds and did all the work for you with this. So this shows you what happens here. NEN for positive electric. So this doesn't matter here. And these are a list of what it would take. This is based on the calculations here and here. Okay. So y and x are here, and x is here, and these are all the different types of valences you can get. And I do want to do a shout out for Professor Wyckoff, who did an amazing amount of work on crystal structure. So I made heavy use of his work, as did Larson himself. All right, so that's iron. Let's just look at a few other things. There's cobalt, again, positive electric, copper, zinc, gallium, arsenic. Now here with arsenic, we have secondary positive electric or primary magnetic, so that's kind of interesting. So secondary positive electric, you can see there's a 3 here, and there's a -3 here. So that's what it is, secondary positive electric. The primary magnetic is down here, so that's another possibility, 3 and 3. 3 and -3. It's got to add up to 0 here. So we have, we have the y and the x's, and we have m and n. Okay. Let's keep going. There's selenium, secondary positive electric. Let's see, where is that? Here, -m times x is 2, n times x is -2. So there we go. So I just want to point out that there are no circling electrons in the reciprocal system. An atom can harbor an electron or two, but electrons are not constituents of atoms. So there's no such thing as covalent bonds or ionic bonds or anything like that in the reciprocal system. That's why I say you need to read Nothing But Motion and the Basic Properties of Matter if you wish to get a handle on the microcosmos. What I've done here with the database is to make everything computational and easy to look up and understand. Now let's just let's take a look at water. So I'll type in H2O. Oops. Oh, sorry. And hopefully this will bring up water, ice. And here we have H for the element 1 and O for the element 2. So look at the different specific rotations here and here. And then you just you pick one of these, one from here, and you get low negative, and you get 0.8613. It's calculated. Can't be interrupted by phone at this time. All right, jeez, came back at me. Okay. So where was I? Yeah, hydrogen and oxygen here. So you put in the specific magnetic rotation here, and here are the possibilities. I always give you the possibilities, and then you put in the specific electric rotation. Same deal here, and these are the calculated 0.8613 angstroms and 0.9945 angstrom. So here, the most probable valence type is secondary magnetic. So where is secondary magnetic? Here, down here. So m times z is 2, and n times x is -2. So that's right. Okay. So that checks out. Now, what do I say here in the these notes are important to study. Let's just see. I use Dr. Danae's from the what used to be called the National Bureau of Standards, Cells in Order Advice. And there's 1H, 2, 3, etc. Other forms of high pressure Wyckoff. I reference this volume 1, pages 322 to 324. Regular and heavy ice, but the coordinates are confusing. I've used my own best inference from the task. Basic properties of matter says that the HO calculation gives 0.92 axioms, which is not negatively different, about 6% from our calculation. Not clear where the error is. I don't know what that problem is. So anyway, in recent years, many forms of ice have been found, and so on and so forth. So anyway, let's see. What else do we have? Here's hydrogen peroxide, for example. The most probable valence type is primary magnetic. So I come down here, m times y is 4, n times x is minus 4, so that kind of makes sense. And here we have H is element 1 and O is element 2. And, you know, I've got 1,344 total compounds together with the elements in here. I have to go back to show them all. And let's see what else we have here. Got some blanks. Let me go all the way back. And like here's the lithium. As you would expect, these are both positive bond types. And here's silver. Now this time we have a combination type, which is like an 8 and a 10. This is kind of interesting with the bond. But the most probable valence type is positive electric because it is a metal. So NEM and NEM, basically. I think I will just do aluminum. This is again positive electric as you would expect. Let's see, beryllium, strontium, boron. Boron is kind of interesting too. This is a positive electric. Again, let's see if I can find something different. Here's a normal electric. The normal electric is M times X, and then N times X. So it's 4 and minus 4 adds up to 0, so that's right. All right, so well, I think that wraps up valence. Again, I put all this data in so you can see what the valences are in the reciprocal system, but you really should read nothing but motion and the basic properties of matter. All right, I'm going to close out valence. We covered it nicely today. Please study the reciprocal system and prove it for yourself. For the simplest possible treatment, please obtain my work, The Unmysterious Universe. It's available from Amazon.com or TranspowerCorp.com, like all of our products. It's only 80 pages long, has all the diagrams, all the concepts, but very little math. If you do want all the math, please obtain my magnum opus, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF file and 711 slides in the PowerPoint file. Thousands and thousands of equations, diagrams, tables, figures, you name it, it's in there. It'll take you months to go through it. Then, once you've completed Existence and Interactions, then you're ready for these 2 database modules. I've already covered the reciprocal system Microcosmos database in these screencasts. This database module covers the universe as a whole, galaxy clusters and groups, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, and voids. It also contains a very nice graphing program for the progression versus gravitation and for star properties. Reciprocal System Microcosmos database. Today we covered valence. This also covers, this database module also covers interatomic distance, specific heat, energy and entropy, thermal expansion, compressibility, electrical and magnetic properties, isotopes, and atomic spectra. Liquid, vapor, and gas matter properties as well, volume and density, specific heat, energy and entropy, viscosity and surface tension, and electrical and thermal conductivity. It also covers cosmic elements and subatomic particles, including material and cosmic subatomic particles, and of course photons. It too includes a very nice graphing package. All right, so that wraps up for today. I will point out I've also made Dewey B. Larson's work in economic theory fully computational. That's my optimal economist package. That covers the economics of individuals and businesses and business sectors. That's microeconomics. It also covers the macroeconomics of countries and regions. Completely supersedes Keynesian economics. I made it very easy to compute all the values in that, and eventually we'll get around to doing some screencasts of optimal economist. Okay, well that's it for today. Please study the reciprocal system, improve it for yourself, and thanks for your attention.